Hello, statisticians. Miss Collier here with some notes for you before you embark on group work, reviewing everything with probability. So I'm going to go through a couple of scenarios with you. Write down as much in your notebook as you feel you need to write down. So our first scenario is we have a multiple choice test. This is really not a test, it's a little quiz. Each question has 5 answer choices, and there are 3 questions on the quiz. So for problem 1, we want to just consider question 1. That's it. If you randomly guess, so you have no knowledge, you're just eeny, meeny, miny, mowing it, you're randomly guessing, what is the probability you get the question correct? Take a moment to think about that. Okay, I hope we all see that that would be 1 out of 5. The 5 is coming from the fact that we have 5 answer choices. And out of those 5 answer choices, only 1 choice is correct. So it would be 1 out of 5. If we convert to decimal, it'll be 0.2. As we work with these probabilities, I find it easier to have them in decimal form. So part B, if you randomly guess, again, on just that first question, what is the probability you get the question wrong? Well, again, the question has 5 answer choices. And out of those 5 answer choices, 4 of them are the wrong answer. So you have 4 chances to get it wrong out of 5, which would be 0.8. All right, so that gives us the basics. Number 2, what is the probability you get all the questions correct? So that is going to be the probability that you get number 1 correct. And then you have to do the probability that you get number 2 correct. And the probability that you get number 3 correct. And well, that's it, because there's only 3 questions, right? So the probability that you get the first question correct, that's a 0.2 probability. Now the second question doesn't have anything to do with the first question. And so we're going to just multiply these probabilities together. This is our multiplication rule. So it's going to be 0.2 times 0.2 times 0.2. We could also express that as 0.2 to the 3rd power. Which is going to give us 0.008. Whoa. If there are 5 answer choices and you are randomly guessing, you have a very low chance that you get all 3 correct. Next question. What is the probability you get all the questions wrong? All right, now be careful here. Some people might be tempted to just subtract your answer for number 2. But there's other scenarios besides getting them all correct or all wrong, right? You could get 1 right. You could get 2 right. So this is not just going to be a 1 minus the other answer scenario. The probability that you get 1 question wrong is 0.8. So the probability that you get all 3 questions wrong is going to be 0.8 to the 3rd power, which is going to be 0.512. So now you've got like a 51% chance that you're just going to get a 0 on that little quiz. Ouch. All right, question 4. What is the probability the first question you get correct is the 3rd question? Take a minute, let that sink in what it's saying. What is the probability the first question you get correct is the 3rd question? So we just kind of have to map out what happened. So that means on the first question, you got it wrong. So your probability of getting the first question wrong was 0.8. And then that means you got the second question wrong also. The probability of getting the second question wrong was also 0.8. But then that means you got the third question correct, so then that was 0.2. So if we multiply that, we're going to get a probability of 0.128. All right, now question 5. What is the probability you get at least one correct? So you really have to be on the lookout for this phrase, at least one. And what we're going to calculate in order to find at least one correct is we're going to take 1, because that's the probability of everything, and we're going to subtract the probability of getting none correct. So getting none correct is the same thing as getting them all wrong. So we actually already calculated that probability up here, number 3. So this is going to be 1 minus 0.512. Whoops. Which is going to be 0.488. Now, I know some of you are still having some struggles with, Ms. Collier, this is the formula. Why? I don't understand. Why is this working? Why are we doing this? So let's go ahead and find, since there's only 3 questions on the test, let's go ahead and figure out the other scenarios. So the probability you get at least one correct. So let's find the probability of getting 1 correct. So if you got 1 correct, that means you got wrong and correct, which is the same thing we did in number 4, 0.128. Well, the probability that we get 2 correct, that's going to be 1 wrong answer times 2 correct answers. Yes? That's going to be 0.032. And then the probability that we get 3 correct, well, we already calculated what is the probability that you get all 3 correct. So that was 0.2 to the 3rd power, which was 0.008. Now, if we add those up, here's what we have to consider here. This could be the probability that we get the first one wrong, the second one wrong, and then the 3rd one correct. But we could also get this one, these 2 wrong, and this one correct. Or we could get the first one correct and these 2 wrong. So we have these different scenarios, but 3 different ways of that happening, yes? And then we could get 2 correct. We could get the last 2 correct, or we could get the first and the last correct, or we could get the first 2 correct. So we'd also have 3 different ways for that to happen. Now, getting them all correct, there's only one way for that to happen. So if I do 0.128 times 3 plus 0.032 times 3 plus 0.008. When I add all of these up, I get 0.488. So if I wanted to find the probability of getting at least one correct, this down here, this is what I consider the long way to do it, right? The probability that you get exactly one correct, but in 3 different orders. And then the probability that you get 2 out of the 3 correct, but that could happen in different orders. And then the probability that you get all 3 correct, and then you have to add them all up. Isn't this way up here, 1 minus the probability of none correct, a lot easier? So that's why we use that formula. Okay, next. Here's a scenario. 8 people have on a purple shirt. 10 people have on jeans. 12 people have on a purple shirt or jeans. Now remember, this is our Starbucks or coffee or cream. Draw a Venn diagram for that. So I'm going to give you a couple of minutes to get that done. All right, let's start taking a look. Hopefully you started by drawing a rectangle. Remember, your Venn diagrams have to be a rectangle so we know what's in our population. And we have these 2 intersecting circles here. Purple shirt, jeans. So when it says 8 people have on a purple shirt, I hope that you did not just put the 8 right here. Because this number is for people who have a purple shirt but don't have jeans. So that number 8 is this whole circle here, right? It's everybody wearing a purple shirt, the ones with a purple shirt and jeans, and also the ones with a purple shirt that don't have on jeans. And then 10 people have on jeans. So I hope you didn't put the 10 right here. The 10 is this whole circle here. Now notice it says 12 people have on a purple shirt or jeans. And you're like, wait a minute. If 8 people have on a purple shirt and 10 people have on jeans, and 8 and 10 is 18, how can there only be 12 people who have on a purple shirt or jeans? What is going on here? Well, remember, we've got this little overlap section, right? So some people have on a purple shirt and jeans. How many people is that going to be? Well, since 8 people have on shirts and 10 people have on jeans, and that's 18 people, right? But 12 people, only 12 people have on a purple shirt or jeans. Now remember that's purple shirt without jeans, jeans without a purple shirt, or both jeans and a purple shirt. So the difference between these two is a difference of 6. So that means those 6 people must have been counted twice. So a 6 goes right here. All right, now if 8 people total have on a purple shirt, but there's 6 that have a purple shirt and jeans, then that means there's 2 over here. Those are 2 purple shirts, no jeans. Maybe they're wearing shorts. And then there's 10 people who have on jeans. 6 of them are also wearing a purple shirt. So that means there's 4 people over here that have on jeans, but they don't have a purple shirt with it. And so then do you see the number of people who have on a purple shirt or jeans is 2 plus 6 plus 4, which is where the 12 comes in. So I hope that makes sense to you. If not, talk about that one at your table. Hopefully somebody at your table has a pretty good idea of it. Now, you're going to be working with your teams on a worksheet. Question 2C is going to ask you a question about M&Ms, and I just want to say that you're not picking M&Ms from a little fun size bag. We're talking about like all the M&Ms in the whole factory. So that'll influence your decision on that question. On the back side, on question 1, that's where you're doing a Venn diagram. So on the back page, question number 1, I suggest a Venn diagram for that. And then question number 2 on the back, there are other ways to solve it, but I would suggest a tree diagram for that one. All right, the answer key is posted on Canvas, but please don't look at the answer key until your team has finished an entire page. All right, so work together, be productive, help each other, and I'll see you tomorrow.